Helicap was recently updated to include the GroutForce piling system. This demo is meant to demonstrate how to input the GroutForce piling system into Helicap and calculate both compression and tension capacity axially. To get started, the user will log in and start at the job screen as shown. We'll create a new job, adding both the job number and the job name. For this demonstration, a job file has already been created. To get started, we will click on this job. As other Helicap runs, this job will start in the job profile section, where we could add job information and any other address details of the project. This is also where we can toggle the type of graphs we want to use, such as a standard graph or a multi-graph. We can toggle between USA empirical units and SI metric units. GroutForce has been updated to have bond values in both. This is also the section where we can add user permissions. As you can see, I am defaulted as the owner of the file, but I have also added a colleague to share and view edit the file as required. It is recommended to have at least one other colleague on all files so that if a user access is lost, the file can still be accessed. From here, we will move to the worksheet section and start our calculation. For this demonstration, I have three different soil types. I have a sample clay, a sample sand, and a sample mixed sand clay. We'll assume we're in a compression mode. We are assuming no water table for the first soil profile and a soft to firm clay over a medium to stiff clay with cohesions of 625 and 1875 psf respectively, and N values of 5 and 15. I am assuming a no-load zone of 5 feet below the surface. The no-load zone should be the active zone depth of the soil, which can vary anywhere from 5 to 10 feet, or alternately the depth to frost. To insert the pile, we will go to the Series tab. For this first example, I'm going to assume a 200 kip pile, ultimate. We're going to assume a depth of 40 feet, an vertical installation of 90 degrees, a datum depth or its relative relationship to grade to be 0, so the pile top is at grade. We're going to select GroutForce as the pile system. And we have 4 different types of piles we can select. An SS225 with an 8 5/8 grout column. We can assume an RS4500 with a 337 wall with a 8 5/8 grout column. An RS6625 280 wall with a 12 3/4 inch grout column, or we can assume a similar RS6625 with a thicker 432 wall with a 12 3/4 inch grout column. For this first example, we're going to use the RS4500 337 8 5/8 grout column. We're going to select the number of helixes. We're going to use the first default of 2 with a 16/16 configuration. Helicap has been updated for all products to have a disclaimer if a product selected is deemed to be a longer lead time or a non-standard product. GroutForce, typically being a project-specific project, will typically have longer lead times, and this disclaimer is shown. From there, we'll select what type of calculations we want to use. We can use a bearing-only calculation, we can use a friction-only calculation, or we can use both friction and bearing capacity. For the demonstrations, we will assume both for all. We'll tell it what type of frictional capacity we're using. In this instance, we're using grout. And then we can select what type of frictional bonds we want to use. There are US Navy values for cementitious material, Governor values for grouted shafts, and the FHWA Type B from the micropiling guide. From testing, it has been found that the FHWA Type B models the GroutForce bond strengths the best. US Navy and Governor both tend to be conservative in their estimates, where FHWA tends to model more correctly the bond values that are obtained. In all these demonstrations, we will use FHWA Type B. At the bottom, we must specify what grout column diameter we want to use. Helicap will default to the standard 8 5/8 grout column. However, if larger grout columns are wished to be used, they can be inputted as a custom value. So if we wanted to use an RS4500 with a 12 3/4 inch grout column, we can override the system and then use the larger column. For demonstration, we will use the default settings. The distance from the tip, or the start of the friction, we're going to assume at 0.5 feet, 1/2 foot above the tip of the stinger. We hit Insert Pile, and a graphical representation of the pile is shown over here to the left, with the 2 16-inch helixes and the grout column. In the graphical representation, we can hover over these I buttons and see a quick summary of each soil layer or we can hover over the pile number and get a quick summary of the pile type being used. With the pile information being inputted, we can now hit Calculate, go to the Table tab, and now the calculation of the pile's capacity is shown with basic information on the pile here at the top, grout column diameter, individual helix capacities, total frictional capacity, and the combined capacity of the pile. A reminder that we were looking for a 200 kip pile, and you can see that we have reached that capacity with a 207 kip compression and 200 kips of tension. For the second example, we're going to use a sand. For the soil profile, we're assuming a water table depth of 10 feet, no load zone of 5. At 0 feet, we have a 10 below sand, and at 10 feet, we have a 20 below sand. The same process going to the series tab. We're going to assume a 23-foot pile, 90-degree installed, 0 datum depth, use grout force. We're going to use the same RS4500 with 8 5/8 column. We're going to again select 2 helices, 16-16 configuration. We're going to calculate again both bearing and friction using grout and the FHWA type B. We don't want to override the default, so we're going to use an 8 5/8 column, and it's going to start 0.5 from the tip. Insert pile. We get the same graphical representation over here. Hit Calculate, go to the table, and we have the individual helix capacities of each individual installation helix. Frictional capacity is shown here, and our total combined capacity, which you can see in this case is 213 kips in compression and 195 in tension. Moving on to a mixed sand and clay. The soil profile, again, we're assuming water table at 10 feet, no load zone of 5, and we're mixed between a 5 below clay and sand, gaining density with depth to a 10 below clay and a 15 below sand. A reminder that if, say, at 25 feet, we wanted to put a mixed soil in, that could be a silt or any other type of mixed soil that has both cohesion and angle of internal friction, you need to input all the values. Helicap has assumptions for bond strength for both clay and sand, and also for bearing capacities for clay and sand, but mix will require you to manually input cohesion, angle internal friction, unit weight, and the bond value. For this demonstration, we will just use clay and sand and use the embedded bond values within Helicap. So the same, we go back to the series tab. For this last demonstration, we're going to assume the ultimate capacity is required is 400 kips. So we'll install a 38-foot pile, 90 degrees, the datum depth of 0, and select grout force. Now, because this is a 400 kip pile, the ultimate compression strength of the RS4500 with the 5/8 grout column that we were using previously is 300 kips. So to maintain an adequate structural safety factor, we need to go up to a RS6625 280 wall with a 12 3/4 inch grout column, which has an ultimate structural strength of 500 kips to satisfy our 400 kip load. Now we're going to select 2 helixes, a 20/20 configuration, which is standard for the RS6625, both friction and bearing. Frictional capacity is grout, and then we're going to use the FHWA type B for our bond strengths. We're going to use the standard default 12 3/4 inch grout column, and we're going to assume that the friction starts 0.5 from the tip again. Insert pile. We're going to have our graphical representation here with the 20/20 configuration and the 12 3/4 inch grout column installed to 38 feet. We hit Calculate, go to the table, and the table now shows the capacity of the pile. Again, individual helix capacities are shown, frictional bond is shown, and then the total combined ultimate capacity. In this case, we have a compression strength of 411 kips and a tension strength of 375. When reporting, the method is the same as a helical design. We go to the print, and then we select what information we want from each soil tab. So for the sample clay, we could click everything and have multi-graph, pile, information of table, and the capacity graph. For the demonstration, I'm going to assume we're just using the capacity tables. Then hit print. A summary report is generated in PDF. And as you can see here, we have the capacity table for our clay. We have soil information for our clay pile. We have the capacity for our sand pile, the table, graphical representation of the pile. We have the soil information for our sand pile, and then our mixed pile with capacities up to 411 kips as calculated with graphical representation and the soil profile shown.